Everyone, welcome back to the AI stage at the Biotech Future Forum. As you know, I'm Elena, your virtual host. Today's panel, Unlocking Unusual Data, Particles, Biology, Space, will explore how unconventional data sources are shaping biotechnology. Please welcome our esteemed moderator, Dr. Miloš Đorđević. Let's begin.
Thank you very much. Good afternoon to everybody. It is a great pleasure of mine and a real honor for me to moderate this panel discussion on a very important topic. So the discussion is titled Unlocking Unusual Data, with subtitles Particles, Biology, and Space. Before we start the discussion with our esteemed experts in this panel, please allow me to give you a small introduction based on my scientific background, which is particle physics at CERN, and also more recently DNA-related biophysics research. So in the last several decades, we have all witnessed rapid technological development, resulting in and enabling major advancements and breakthroughs across multiple scientific, industrial, and societal disciplines. These developments often require processing, but also frequently created a large amount of data, sometimes of a very unconventional nature in terms of its origin, how this data should be stored, how it could be processed, and which information could be extracted from it. The development of computing resources and IT infrastructure has tightly followed this process and was often driven by the above needs. One of the most prominent examples of this kind is the Large Hadron Collider at CERN, where the most powerful accelerators ever built, and some of the most complex machines, being the adjoint particle detectors, such as ATLAS and CMS, famous by the discovery of Higgs boson in 2012. These accelerators and detectors, they store and they process petabytes of raw data each year. If you store this data on a CD and you stack all of these CDs, you would exceed a height of an Eiffel Tower every year. This data is after storage then scrutinized by physicists. Now, researchers from the Republic of Serbia have long time participated at CERN, and Serbia has been a full member of CERN since 2019. The algorithms of artificial intelligence have been extensively used already for many years and have become mandatory for the treatment of data produced by the experiments at CERN. While the collisions of high-speed, infinitesimally small particles, such as protons, occur at almost infinite energies, producing extremely large datasets, many other uncommon and unusual datasets do exist nowadays, such as the complete sequence of a human genome. DNA-related research is critical, in particular, in the view of opening new possibilities for drug discoveries. The evaluation of DNA damage upon irradiation by hadronic particle beams for cancer treatment also creates large datasets, where the usage of artificial intelligence becomes mandatory. Now, in this discussion, our panelists will present their experience, they will showcase their expertise, but will also give examples on how to unlock the unusual datasets. Now, I would start the discussion, I would kindly ask Dr. Mihailo Jovanović, Director of the Office for IT and E-Government of the Government of the Republic of Serbia, to present the strategies of the Republic of Serbia related to the existing resources regarding storing, processing, and handling the large datasets, as well as plans to improve on these resources through upgrades and developments in the near future. Now, since the opening of the State Data Center in Kragujevac in December 2020, could you also share which types of data are currently stored there and what additional datasets are planned for the center to move forward? Thank you.
Thank you very much. Hello to everybody. Thank you for the opportunity to participate today at the Biotech Future Conference, and this opportunity to talk about our digital infrastructure and the projects that we are running in the government of Serbia. We recognize as a government that in the fourth industrial revolution, the data is power. And we decided in 2017 to force the digitalization as one of the main priorities of the government. And we started to invest and to develop our digital infrastructure, that means our digital network, and our digital infrastructure, that means our data centers. And we are especially proud that at the moment we have two data centers, one in Belgrade and one in Kragujevac. First one in Belgrade was established in 2017. It meets the Tier 3 plus standard, that means more than 3T and less than Tier 4, which means that it provides a high level of availability and reliability. And capacity of a Belgrade data center is around 200 racks cabinets, and after 7 years, after the establishing, it's full of equipment. There is no free space in Belgrade data center. So I'm very proud that we decided to build second one, government data center in Kragujevac. We started the design in 2018, to build in 2019, and we opened the government data center in 2020. And I can say that the main symbol of digital transformation in the Republic of Serbia is government data center in Kragujevac. It consists of 2 facilities, one for the public administration, local self-governments, and even commercial users. The second one is for Ministry of Interior, Ministry of Defense, and Special Services. And it was built according to the highest technical and international standards. This is the first data center in this part of Europe that received European EN 5600 Class 4 certificates for data centers, the first data center in Eastern and Southeastern Europe. EN 5600 is European standard that refers to the design, construction, and management of data centers and similar digital infrastructures, which only 8 data centers in Western Europe have. So we are unique in this part of Europe. And we provide service level agreement, SLA, service level agreement of 99.995%. That means that we can go down just for 15 minutes per year, but it wasn't happening until now. We provide also the capacities of government data center in Kragujevac to big commercial customers, the larger global IT giants like Oracle, IBM, Huawei, and others. Probably one of the biggest customer is Oracle, providing their own public cloud from our government data center. Also in the government data center, we keep our first national platform for artificial intelligence. This is the latest generation of Supercomp, HPC, and we provide free of charge the capacity of our Supercomp to universities, scientific institutes, faculties, science technology parks, and domestic startups inside the science technology parks. I would like to mention that through government data center we provide 2 main services. This is obviously government cloud and telehousing, and we have top engineers and experts guaranteeing data security and efficiency 24 hours a day. We have in government cloud more than 350 different information systems for over of 70 different public institutes and state entities. Also, we provide telehousing in our government data center, and it is very important that we have a very good network operation center in real time 24/7, as well as security operation center in real time, which is very important for the security part of all our data and systems in government data center. And in the end, the capacity of existing 2 buildings in government data centers are, power supply capacity is around 14 megawatts. And according to the project Serbia 2027, we have planned to expand, and we are now doing the design of the government data center by building, we call it Block 2, with the capacity of more 16 megawatts. So we are going to double the capacity of our government data center. And we are working also on the construction of innovation district. This is some kind of part 3 of a government data center. We will have there the place for members of IT community, the place for National Center for Information Security, And we are going to build even the 5th science technology park in Serbia next to government data center.
Thank you very much, Dr. Ivanovic. This really reminds me the strategy on how to upgrade the center on several strategies of how they improve and upgrade the accelerators at CERN. So you're referring to part 2, part 3, like phase 2, phase 3 upgrade of the LHC. And now I would move the discussion to the question to Ms. Markovic. So nowadays we are all aware of, unfortunately, increasing rates of various diseases, of which cancer is one of the most difficult to control. Now, development and testing of new, more effective drugs became mandatory in this regard. So, Ms. Markovic, could you please tell us a little bit more on how computing and how bioinformatics, which is your domain, could improve the discovery of drugs?
Yeah, of course. So obviously, like in the previous panels, this has probably been discussed a lot more. So it's a very high-level question. I'm going to try to highlight the unusual data sets that we can use in the process. So just to set up the framework, I'm going to repeat what probably every other panel has already said. Drug discovery is a lengthy process that's going to take 5 to 10 years. It's going to take between $500 million and $5 billion, and it's going to fail 90% of the time. So there is obviously a lot of space for improvement there, right? Because, you know, if someone gave you $5 billion and 10 years to make a car, and 90% of the time it goes up in flames, there's obviously a lot of space for improvement. So within this process, there's obviously different stages, and the earlier you fail, the better, because it's going to cost you less. And I think that a lot of computational methods currently are actually focusing on that part. So kind of like preventing or actually failing before you get to the patients and you actually impact lives. So in this earlier stages of drug discovery, what I want to highlight, again, on a very high level, is the use of these large proprietary data sets where you can actually screen a large number of compounds, and you can actually train machine learning models to guess the properties that could affect toxicity and other range of activities in specifically, for example, cancer cells. But what I would say are unusual data sets that would be interesting to highlight, and what are some ways in which you can use computation to get drug discovery more successful and get the process done faster. So I can think of two very interesting examples. The first one actually got the Nobel Prize just this year, and it started with something called Foldit that people are probably familiar with. It's so this lab at Washington University actually gamified process of protein folding. So protein folding is a very like it's a process that doesn't necessarily follow a specific set of rules, and it's really hard. Like if you gave a protein sequence to like 1,000 people, they would not be able to come up with a protein structure based off of that sequence. So what this lab has done is they actually created a game that was running, I want to say from 2011, and people would play the game to come up with the most stable protein structure, and they would, like, in the end, the most stable protein structure would be checked against the actual crystal structure. And crystallizing a structure takes, like, you know, year if you're lucky in the lab. So I would say that crowdsourcing is an interesting and unusual way to get to the data that can actually help you speed up drug discovery process. The second example that I thought of was actually using these like molecular dynamics, which is something that we have not been able to do until very recently. So you definitely need a supercomputer, so you need a lot of money to run it. But there is, for example, amazing research done where you can differentiate between a cancer mutated protein and a normal protein based off of how that protein moves within the cell. And based off of this movement, you can actually design a molecule that can target the cancer version, but not the normal one. And, you know, earlier, if you wanted to simulate this kind of behavior, it would probably take you like a very long time. Today, to produce this kind of thing, it's a lot of computational power and hours, but it's definitely something that is doable and that's already giving some results in the clinic. And finally, like in the later stages of this process, there's very interesting research into something called digital twins, where you can actually take as much data as you can on the patient cohort that you're planning to do the clinical trial on, and run a simulation and see what kind of profile of the patient will respond to the drug and which one will not, which can actually increase the chances of your clinical trial going well and actually delivering those drugs to the proper population of people. So kind of like going back to the points that the previous speaker made on the data centers, I think that the way a country can get ahead in these areas is actually through the initiatives that would create like legislature, but also the like physical data centers where you can store these types of data. And the countries that have done it are already ahead, but it's definitely way early in the game. So, you know, anyone who joins now is it's a great time to get started. The more data we have, the more we can actually train these models, the better legislature we have, the better we can protect the privacy of the people, and we can protect these data and store it properly. And then finally, we can actually improve the life of hopefully many. Hope that answers it at least a bit.
Thank you very much. This is really detailed and comprehensive. Thanks a lot. Now, question for Mr. Molan. Sorry. If you are ready, so you have participated in the Open Lab project at CERN. Could you please tell us more about this project? So what was your role there? What was your contribution to this project? And how the artificial intelligence could ensure the safety and smoothness of operation of CERN accelerators? This is what I'm in particularly interested in as a particle physicist.
Thank you for the question. First of all, thank you so much for the invitation. I feel really honored to be part of such a panel. And I also really like the question because it shows that the moderator has really done their homework. This was indeed, I've done this years ago. This was very much the beginning of my scientific career. And I distinctly remember I was on the project where we were finding anomalies for a linear accelerator. And I know this might upset some people on the panel, but I also remember the fact that, of course, I was honored and excited about the fact I'm working for CERN, but I also remember the fact that I really didn't care about the linear accelerator or the application of my work. But the aha moment for me was, okay, can you still hear me now? If I'm here? Yeah. Okay. Thanks. So the aha moment for me was the fact that, okay, I came to CERN, which is probably the biggest concentration of exceptional and smart people in the world. And we had this problem, which was a machine learning problem, well-defined problem with the data set, but it was still open. And it was still a scientific open question that needs to be solved. And this was sort of, this very much informed the trajectory of my career going forward. Because if I'm looking at it back, what differentiates these interesting, difficult questions which are extremely underexplored and really crowded areas? I think it's exactly the modality of the data. If you look at how you solve the, for instance, operational data analytics problem in general, which this really falls under, is that you create a model which is fine-tuned to that specific data set and then specific problem, right? You don't win by brute force, by training a model which is larger than anyone else's. You don't win by having more GPU or more electricity, but you really win by being creative and being clever. And that was really a fascinating moment for me. And I said to myself, okay, I want operational data analytics and these unusual modalities of data like telemetry, sensor data, time series graph, all these things which cannot be covered by like large language models, large multimodal models, all these kinds of things. I want to focus myself on that. And that then was the focus of my scientific career. And also now that I'm transitioning to industry. By the way, I know I'm in the panel full of doctors. I am not yet, but I'm going to be soon. I'm finishing my PhD next week. So now that I'm also transitioning to industry, this will also be the focus, not just of my work, but the identity of our company itself, right? We want to focus on the problems where you win by being clever, where you win by being creative, right? And this is intrinsically connected to underexplored, unusual, difficult data and difficult problems that they create. So yeah, I know my problem is a little bit disappointed, but even when I was in CERN, I don't remember anything beyond the impact of my work beyond that, you know, okay, our linear accelerator was breaking down. Now it's still breaking down, but at least we know about it, so we are extremely happy about it. And, you know, I was satisfied with this. But, you know, what remained was the fact that, okay, these types of problems, this is something worth exploring.
Thank you very much. I will have what to summarize at the end, surely. Now, a question for Dr. Drašković. So being the head of exploration at United Nations Development Program, can you please share with us how the artificial intelligence is transforming the approach to sustainable development challenges?
Thank you, Milos. Hello, everyone, and welcome to the session. Happy UN Day. Today is 79th birthday of the United Nations. On this day, 79 years ago, the UN Charter entered into force, so to everyone. Well, AI is a general purpose technology, and it's like electricity. It has the potential to disrupt our society, our economy, industry, governance, and some people claim that it could redefine what it means being human. AI can help address global challenges like climate change, poverty, and inequality. It can, for example, optimize energy consumption. It can develop sustainable development technologies and improve access to education and healthcare. It can enhance human well-being. AI can automate mundane tasks, freeing humans to pursue more meaningful work and leisure activities. And additionally, AI-powered tools can assist people with disabilities, improving their quality of life. AI can accelerate scientific progress. We've seen in the past few weeks 2 Nobel Prizes in physics and chemistry awarded to AI scientists, Geoffrey Hinton for neural networks and Demis Hassabis from DeepMind for AlphaFold 2 protein folding that was already mentioned by Milica. AI can analyze vast data sets in identifying patterns, generating new hypotheses, leading to breakthroughs in the fields like medicine, material science, and climate modeling. It can improve healthcare, which is a big part of this conference. It can revolutionize drug discovery, disease diagnosis, treatments, leading to improvements in human health. For example, AI-powered systems can analyze medical images, identify early signs of diseases, and develop personalized treatment options. At the UNDP Accelerator Labs Innovation Unit, so UNDP, we experiment with AI, and within the network of 90 labs, more than 20 labs have already had experiments. We had 27 experiments using various AI techniques, from supervised, unsupervised learning, deep learning, generative AI. Basically, our aim is to understand well what data with what AI techniques are best suited for what sustainable development challenges and priorities. AI is being utilized in areas like, as I said, climate action, healthcare, education, and across the UN system, there are more than 400 projects at the moment impacting all 17 Sustainable Development Goals. We have a repository that is online. You can have a look. It's called AI for Good. And all AI-related projects are listed there. Of course, all these projects have the potential to accelerate progress toward the Sustainable Development Goals. Unfortunately, despite all these benefits, there are many challenges and risks, such as ethical concerns, like bias. When I talk about bias, of course, it's racial, gender bias, ethnicity, ages, many types of biases. Privacy issues with data sets. Of course, especially for health applications, it's very important to preserve privacy. Social impacts, misinformation, disinformation, potential job displacement. Technical issues, data quality, system transparency. Many systems are black boxes. We don't know what's going on inside, so we promote open AI models. Of course, potential misuse and loss of control. There are many AI doomers saying that basically at one point humans will lose control. Some barriers to adoption, key barriers to adoption of AI in international development include lack of technical skills. We are talking about the global south, the developing countries, the majority of the world. Basically, the need for upskilling, varying levels of trust in AI, computational resources that are not available to everyone, and the rapid pace of AI development that is not in line with regulatory frameworks that are always late. Environmental footprint of AI energy consumption is also a concern. And the other problem is AI governance. Basically, global collaboration is extremely important for establishing AI governance frameworks, and the United Nations has been doing work in this area. We need to ensure ethical deployment of these technologies in alignment with human rights. And by fostering this responsible AI development, scaling innovation, scaling out, scaling deep, scaling up, and increasing AI literacy, AI could be a driver for inclusive growth and sustainable development globally.
Thank you very much. Now we move to the second round of questions. Now, Dr. Jovanovic, we know about the initiative and efforts related to establishing a Tier 1 computing center in Serbia to support the CMS experiment at CERN, one that I also participate in for many years, on which also a memorandum of understanding between the Republic of Serbia and CERN was signed in December last year. So could you please give us more details about it? Why storing the data from particle collisions at CERN in the state data center in Kragujevac, Republic of Serbia, would be important for our country? And also, and in particular, what could we learn from these efforts?
We are extremely proud that Republic of Serbia is one of the only 24 countries of the largest scientific laboratory in the world. This is CERN, European Central for Nuclear Research. And we are investing a lot in science through that center. Last December, government of Serbia signed a memorandum of understanding on cooperation in the introduction and exploitation of the worldwide Large Hadron Collider computing grid in the government data center. That means that signing this memorandum, we will become part of CERN worldwide computing grid. That means that we are going not just to store data from CERN, but also to analyze and to process data for one of the 4 main experiments. This is CMS. CMS is compact muon solenoid, and it is a general purpose detector in the Large Hadron Collider. and our intention is to be tier 1. That just to explain, CERN itself is tier 0. So there are just 10 countries in the world with tier 1, and there are several countries cycled to tier 2. So our intention is to become tier 1, and we will be perhaps the first country that will immediately become tier 1. The goal is to quickly reach 10% of the total capacity of total tier 1 resources, and according to the signed memorandum, we will store a total of 45 petabytes of data. The entire system in Serbia, that will be the part of worldwide Large Hadron Collider computing grid, will be designed by our own engineers, and I'm very proud that we have such kind of engineers in Office for IT in the government in Belgrade and Kragujevac that are going to design the system by ourselves. Also, it is very important to mention that through this project, we are going to expand the cooperation with GÉANT. GÉANT is Pan-European High-Performance Computing Network, through which we will be connected to CERN, but also to other Tier 1 and Tier 2 centers worldwide. And also we are going to connect to GÉANT through the capacities of AMRES, our academic network. In the end, I would like to say that it is also a great opportunity to develop and profile our experts within the scientific community in Serbia who will work with nuclear research data and have opportunity to collaborate with around 5,000 scientists from more than 200 institutes and 50 countries around the world on the same experiment. I believe that we will start with production next year, and our intention is to reach the full capacity of Tier 1 in Kragujevac in next 3 years.
Thank you very much. You just answered at the end what was I supposed to ask when the start is expected. Thanks a lot. Now, Ms. Markovic, to post a second question for you. One of the shortest paths toward making new drugs is the repurposing of the current ones. Knowing the characteristics of these drugs that are already used, and in particular their possible side effects. Now, please tell us, could the artificial intelligence and machine learning methods be used in the process of optimized selection of drugs that could be repurposed?
Yeah. So again, going back to how complicated and expensive the whole process is, obviously, if you can cut corners but stay safe, that's a preferred strategy. So repurposing drugs, I think, has been something that has been done even before the revolution, the AI revolution. But now with those technologies, I think what they really enable us to do is identify the patterns that a human brain cannot really find within such large amounts of data, be it like genomic data or metabolomics or all kind of omics data that you can collect. So having a computational system, like a machine learning model that can actually go into those data, find the patterns that are similar between two diseases, and then help you use the drug that's used for one for the other can be very helpful. Two cases that come to mind where this repurposing can be extremely useful are actually the times of emergencies, which are usually like public health crisis, which was COVID, which happened now 4 years ago. And at those times, you don't necessarily have the time to go and go to the lab, synthesize something, test it through the entire thing, because by the time you are done, time has passed, and a lot of lives have been lost. A very interesting example actually comes to mind. There's this startup, I think it's called Benevolent AI, and they managed to do one of the fastest repurposings of a small molecule drug that was used for, I think, arthritis. It's like an immunomodulatory drug, and they managed to repurpose it I think in about 4 months for some of the cases of COVID where other lines of therapy were failing. So, you know, in any future public health crisis, that would be one approach that would definitely speed things up. The other good application of this is actually in the rare disease area, because when you have, like, there are about 7,000 rare diseases that are currently known, and they affect very small percentage of people. However, you know, when it adds up, it's around, I think, 300 to 500 million people that suffer from one of these disorders. However, it's really hard to get the funding, and it's really hard to assemble a cohort of patients. And generally, it's, I mean, drug discovery in itself is super expensive. And, you know, once your cohort is down to like 1,000 patients you can help, very few people from the business side will approve that. And there are initiatives. I think probably the best one that I know of is an initiative that is started at Harvard Medical School that is this very specifically trained machine learning model that is trained on all aspects that they could find of these rare diseases, and then also of all the currently approved drugs. And it's actually already showing some very promising results where they have already identified some of those candidates, and they can move forward to like late stage clinical trials and get them approved a lot faster.
Thank you very much. This is extremely interesting. Now, Mr. Molan, could you please tell us about the Italian supercomputers at the Sineca data center, because you dealt with them as well. So tell us, please, what are the main characteristics of this high-performance computing consortium, and what could we learn from them? So we know, and we've heard already from Dr. Jovanovic, that connecting resources is very important. This is demonstrated at CERN through many years of the Large Hadron Collider and with the Large Computing Grid, where you share resources and you get them at request. But now, what is your experience, and what is your view on why connecting and joining resources is so important nowadays?
Thank you for the question. Yes, this is still my ongoing research topic. I'm a PhD student financed by Sineca Supercomputing Center also. And yes, I think that from my perspective, maybe not the most important one, but for sure an extremely overlooked aspect of how you operate a supercomputer is how efficient you are in doing that, right? And it's both in terms of energy efficiency, system availability, and in general getting the most out of the expensive machines that you got. So in that perspective, connection between different data centers, sharing of the ideas, sharing of the data sets, sharing of the resources is exceptionally important, because again, it is a relatively underexplored topic, and which is full of extremely difficult technical challenges. And the more people that are working on this, the better sort of ideas that you can have. So inside, when we talk about the ongoing research trend within the supercomputing centers, right? When we talk about using AI to manage this, the name of the game is that, okay, we have an extremely expensive machine which is producing a lot of data, and it's impossible for a human system administrator to make any sense of this, right? So we have to introduce some algorithms to help them in that. And what's the first thing that you want to achieve when doing so? You want to be energy efficient. You don't want to do a lot of compute jobs when your cooling is expensive, for instance. Secondly, you want to get as much, you want to get as much as possible out of your extremely expensive machine. We have a saying in Italy, if you have a Ferrari, you want to drive it. It's the same with the supercomputer, right? So you don't want to have failures. You don't want to have downtime. So this is, and of course, applying machine learning algorithms like anomaly detection, predictive maintenance yields incredible results in both scenarios, but specifically in making sure we optimize the availability of the supercomputer, right? For instance, in Sineca, we have already developed a system which we are now rolling out, where we can predict failures with extreme accuracy up to 16 hours in advance, right? So if the supercomputing node will fail, we know 16 hours in advance that we will have problems, right? So pretty much every sort of downtime, any sort of failure, we can not only anticipate, we can anticipate with a long enough window that we actually prevent the failure. And again, because I'm leaving that world next week, an interesting aspect of this, for me, is that it is that the world of supercomputers is an extremely fertile breeding ground and an incubator for development of specific types of AI, which will be extremely important which is extremely important currently, but will be extremely important for the future generations of the problems, right? I think that, of course, we are all familiar with certain trends in AI, but this real-time, complex, heterogeneous data analysis is sometimes overlooked in terms of, especially in the context of industrial informatics, telemetry data, and real-time analytics. Because, for instance, as an example, the anomaly detection algorithm, which I have developed for Chineka supercomputer, and we have first deployed it to, see when our computer is breaking down. Then we took the same idea, the same basic algorithm, and we applied it to a commercial use case in one of the companies within Comtrade Group, where we have it running as a checker to ensure the availability of an online gambling platform, right? So the point that I'm trying to make here is that this sort of of course, it's important to solve problems for the supercomputer because they are the infrastructure of the future, specifically because of the rise of AI, right? But not because of that. Also, if we are solving the problems for supercomputers, we are creating ideas, we are creating approaches and algorithms which will have wide range of applicability.
Excellent, thanks a lot. Now, Dr. Drašković, could you please provide insights into how the artificial intelligence, particularly through experiments involving satellite imagery, is being utilized to address environmental and resource challenges like waste management and climate resilience? What opportunities do you see for AI to contribute to mitigating pressing global crises?
Well, satellite data is, satellite imagery is most often used data type within our research network because it's widely available and AI techniques are well developed. So satellite drone imagery, that's opening up new ways to tackle some of the most pressing environmental and resource-related challenges. Earth observation data combined with AI can support everything from tracking pollution to tracking land use, improving agricultural productivity, monitoring crop diseases, soil conditions, etc. An experiment that we've done in Serbia, we wanted to map illegal dump sites along Serbia's Lim River. It's 100 kilometers of the Lim River in Serbia, using satellite imagery of high resolution and artificial intelligence. That was a collaboration with the European Space Agency Earth Observatory. We trained an AI model using data from known dump sites across Serbia and then applied it to recent satellite images of the Lim River. Our model identified the potential sites. Then through expert verification, we narrowed it down because, of course, there were some false positives. So we narrowed it down to 61 locations, up from 23 previously recorded. However, our experiment revealed some limitations of the AI accuracy due to insufficient training data, due to low image resolution and visual similarities between dump sites and other similar land features. Despite these challenges, we demonstrated a novel way of use of AI to basically combine it with space satellite data. This kind of experiments are key to understand how AI can be used effectively in environmental monitoring, resource management, as long as we learn, of course. AI has the potential to address other global challenges that go far beyond waste management. For example, helping us model extreme weather conditions, monitor deforestation, support urban planning, optimizing resource allocation in areas like water management, energy consumption. And the key challenge here is ensuring that these AI solutions that we pilot are built to scale. and are built to be adapted to different contexts, especially in the low-income countries and middle-income countries. Serbia is upper middle-income country, but there are countries where resources are even more limited. AI-driven technologies could also contribute to mitigating larger global crises such as climate change, resource scarcity, and we are actually using these predictive models to inform our decision-making, to plan our interventions, and to follow up on these interventions. Another fascinating application of deep learning is a system that is called early warning system. We had floods in Serbia, and a few weeks ago in Bosnia, the big floods in Serbia 10 years ago, and in Bosnia also a few weeks ago. For these events, extreme weather events that are becoming more frequent, it's extremely important to have early warning systems. UNDP has been doing a lot of work around that. For example, in Asia, where floods are even more frequent, flood AI monitoring dashboard was developed in Nepal, where it integrates satellite data, sensor data, and historical information to predict flood indicators. That helps humanitarian and emergency response teams to plan proactively and allocate resources more efficiently.
Many thanks for this very detailed answer. We are moving to the final round. The time seems to be ticking off, so I would ask kindly our panelists to be a little bit more concise in the answers, not limiting them, of course. So now the question for Dr. Jovanovic is, please emphasize the roles and the possibilities provided by the National Platform for Artificial Intelligence operating in this center. How does this platform support AI development in Serbia? And also, which sectors or projects are benefiting mostly from its capabilities? Additionally, from Serbia's perspective, how do you see the country's position in the global AI development landscape, and what are the future plans for expanding its use, in particular in the areas such as healthcare and public services?
In 2019, we adopted as a government the strategy for the development of artificial intelligence for the period until 2025. This makes us the first country in Southeast Europe and only the 26th country in the world to have such a strategy. And based on that strategy and many other activities, we became a member of the global partnership on AI as one of only 29 countries in the world. This year, Serbia has been given a great honor to chair the global partnership on AI for the next 3 years. That means that December 3rd and 4th in Belgrade, we will host the ministerial summit of the global partnership on AI. I would like to mention also that in 2021, the Institute for Artificial Intelligence was founded, which now has over 60 researchers in Novi Sad. Serbia also has its own national AI platform. This is the supercomputer made available free of charge to universities, faculties, institutes, and domestic startups companies. So far, there are 38 institutions and 35 startups doing something on that our AI platform with more than 360 user accounts. The first major application of artificial intelligence in public administration and the healthcare sector in our country is the AI software made by our Institute for AI on the national platform that automatically analyzes and ranks mammograms according to the level of priority. This application is hosted in Government Data Center in Kragujevac. It is in testing phase, and we will start in production at the beginning of the next year. I would like also to mention that additionally that at the beginning of its mandate, the new government showed an exceptional commitment to digitalization and new technologies, and especially artificial intelligence. Already in the first 100 days of government work, the Prime Minister formed the Council for Artificial Intelligence, which includes eminent experts from public administration, economic sector, universities. And at the moment, our supercomp in Government Data Center is NVIDIA 4DGX, with 32 GPUs and 150 terabytes of data storage space. This is 5 petaflops of AI performance. The beginning of the next year, we are going to upgrade our supercomputer with 6 more latest NVIDIA 48 GPUs. They are 7 times faster than the existing system. And until the end of 2025, we are negotiating with the French government to procure Bull Sequana supercomp with 640 NVIDIA super chips and with 2.5 petabytes of data storage system, and we will have really huge the capacity of our supercoms. Also, I would like to, at the end, to mention that we are working as a council on a new strategy for AI, and I believe that government is going to adopt new strategy until 2030 by the end of November.
Thanks a lot. I have to add that myself and also colleagues from my group in Vinci Institute, we are already using these resources in our DNA-related research for several months already. It's been very helpful, and we are also looking very much forward to the upgrade that you just announced. Now, question to Ms. Markovic, when it comes to contagious diseases such as the COVID-19 crisis we all experienced, could bioinformatics data and artificial intelligence be used to predict pandemics and also to prevent or cure diseases of this kind?
Yeah, so we have all faced and lived through the COVID pandemic, and well, for what it's worth, in comparison to previous pandemic events, COVID-19 was certainly the largest data collection event when it comes to public health. So having all the experience and the data, coming from that and understanding which practices were good and bad, I think that there's a lot of ground to actually develop much better algorithms that will help us deal with the next pandemic. As I've mentioned, drug repurposing can certainly be the fast track to get to the new medicines for any kind of pandemic that would occur in the future, but also, having the data from the previous pandemic and obviously using it in the ethical and legal ways, we can still get a lot of benefits from it, in terms of resource allocation, considering that when you're in the middle of a public health crisis like that, there's very little time to act on it. And having some sort of technological support that will help you allocate your resources best while not disrupting the regular life, which is essentially the goal of handling the pandemic. As well as on the bioinformatics side, obviously, I think that by the end of the COVID-19 pandemic, we already had pretty good ways of predicting what next strain could come up, what's the most likely mutation that could happen. And it can definitely help with developing new treatments much faster. Hope that was concise.
Excellent, thank you. Now, question for Mr. Molan. Could you please tell us something about the Rascosa project at the European Space Agency that you participate in, and what is the main goal of this project?
Thank you. First, a clarification. We are participating in the project with ESA SCOMTRADE. And maybe I would take a step back first and answer the question, why is SCOMTRADE even caring? Why is SCOMTRADE in the space sector? I mean, SCOMTRADE is a behemoth. We are, if I'm not mistaken, the largest IT company in Serbia. So there has to be a very good reason why we are so interested in space. And we have, specifically when it comes to AI, we have a very clear ambition. We don't want to just be good. We don't want to be followers. We want to be exceptional. We want to be the clear leaders in a specific domain. And this is exactly why we're so interested in space. Space is one of those fields which is full of really tough, really challenging, really difficult engineering questions. And you can only solve them effectively if you are creative, if you're clever, and if you have a great team. So for us, being participating in a research project with ESA, with other partners in the space sector, is a vehicle to demonstrate that, to demonstrate our scientific leadership in the fields as they are relating to operational data analytics, real-time processing, which is, of course, powered by AI. Now, this specific project, which we are working with ESA very quickly, it's about predictive maintenance, anomaly detection, and ensuring reliability in space. But again, you want to do monitoring, you want to do anomaly detection, but you want to do it in an environment which is extremely energy, compute, and thermally constrained, right? So whatever works on Earth, whatever wealth of algorithms you could have in Earth, this simply doesn't work in space, right? So you have to completely shift your paradigms if you want your solutions to be applicable to that field. And this is what is so interesting for us in this field. So yes, we are interested in space, but again, we see it as a vehicle to motivate and develop our engineers to reach exceptional results in the field of AI, which go far beyond the target domain. Hope I was quick enough.
Excellent, thank you. So the last question of the panel discussion today goes for Dr. Drašković. Now, with the rise of the AI's use in large datasets, such as those in migration and tourism, how do you see AI contributing to better predictive models for population movements? Moreover, what frameworks or ethical safeguards are in place to ensure AI remains accountable and transparent, particularly in high-stakes decisions?
Thank you, Miloš. I'm going to focus on our work in Serbia. Of course, migration dynamics is a theme that is important everywhere, and it is influenced by complex factors such as economic conditions, climate change, or conflict. But Serbia is experiencing depopulation, and migrations are a part of that puzzle. And we wanted to better understand migration dynamics in Serbia. So we experimented with Facebook data, LinkedIn data, Google search data, mobile data, satellite night lights, job ads, etc. So the importance is that all the data that we work with was anonymized, aggregated, privacy thresholds were well defined, and we used differential privacy that added artificial noise to data sets so that it enabled us high quality results without identifying any individual person. But maybe just one example was collaboration with the Biosense Institute and Telekom Serbia on a project that was called Pop Insight, where mobile data was used to better understand internal migrations and to better recognize patterns of daily migration. Interestingly, advanced statistical methods help us a lot to derive key indicators from mobile data, mobile activity, connectivity, and mobility. We worked on a municipal level and calculated correlations between these indicators. One of the main findings was that the weaker telecommunications a municipality has with other municipalities, the greater the risk of depopulation. And mobile data is a good proxy for economic activity. It can serve as an early warning system, but should be used carefully, and it should complement other traditional demographic methods. One thing that is of course important is to ensure that AI models do not perpetuate biases. To prevent this, we wanted our system to be built with transparency and accountability at its core. We prioritized fairness, and we included human oversight. Furthermore, it's important to use AI responsibly with safeguards in place to ensure that it contributes to fair, ethical, and transparent decision-making process. AI alignment is another big area of discussion these days. UN is promoting encoding human values and goals into AI models, especially now with large language models, to make them as helpful, safe, and reliable as possible. Regulation is very important. European Union is doing a lot of work with the EU AI Act. But in general, we need to increase our efforts in analysis, benchmarking, and evaluation of AI models. And we need to have scientific approach. Science can save us here. So basically, it's crucial to use the scientific approach to minimize mistakes as AI technology advances, looking forward into more advanced AI of the future, powerful AI or artificial general intelligence that some experts think is 5 or 10 years away. It's very important to have broader societal discussion on the values and goals we want AGI systems to have, and this could be a UN question because it's geopolitical.
Thanks a lot. We may have 1 or 2 questions because of the little time left before we wrap up the session. So if anybody has a question for anybody in specific, yes, please.
Martin, well, we work in the same company, but it calls my attention when they were all talking about how complex it is to have access to computing power. How do the little people compete? Because you have to go against Microsoft, the big guys, the people who have specific access to computing power. How the rest of the people will do? Is it AI limited to a few, or there is openness?
I think the answer to this is simple. I mean, we don't compete with the giants, right? Or we don't compete with them on their terms. As far as my perspective on this question is, you have generally 2 types of competition when it comes to AI, right? You have one class of problems where you have large data sets available, right? This would be regular data modalities. This is text, this is images, this is video, right? The rules of the game there are extremely simple. Whoever can come up with the largest accumulation of energy, GPU, and of course, smart people, but only as a third option, and trains the absolute largest model, wins, right? It's very simple there. So to try to compete in that game is really doomed to failure from the very start, right? But in that sort of area, we can use those models. They're extremely powerful, but we have to be aware that when we are using large language models, there is very little value we can truly add, right? We can use them as glue, as the integration layer, but to add value, we have to do something different, right? So this is why I think this panel is so important, because we are focusing on these unusual data modalities, right? And I think this exactly is the key to be competitive. Because what's the key of unusual data modalities, right? You don't have enough data to just win by brute force. You win by being the most creative, right? To see the problem differently. Because for most of our flagship achievements in the operational data analytics, they could very easily be trained on a already data center owned by Comtrade, right? You don't, I mean, of course, you cannot train them on a laptop, you need decent machines, but you don't need to build a new nuclear power plant to be competitive, right? So the question, so this is why we are focused, this is why this is our identity. And then, of course, we are not ignoring everything else, but we know that we use it just as a glue, but the core value is delivered by focusing on the unique and difficult problems.
Thanks a lot. If there are no more urgent questions, I would just briefly summarize, wrap up the panel by repeating a couple of quotes by our panelists that I managed to catch and to write down. So Dr. Jovanovic said in the beginning that data is power, and that also Serbia is on track in regards to AI development, first through adopting the strategy on AI, and in particular, giving the opportunity to chair the global partnership on AI in the next 3 years. Then Ms. Markovic stated that in relation to the drug discovery, you need to fail many times, but to rise up in order to succeed. And then Mr. Molan also reiterated again in this question that the statement which I particularly liked, which says, win by being clever and by being creative. And also, Dr. Drašković summarized and stated that the AI may be a game changer, like the electricity, like the discovery of electricity. And some people also believe that it can redefine what it is like to be a human. And he concluded with the statement that science can in fact save us. Thank you to all the panelists, and thank you to all the participants for this fascinating panel. Thank you.